Rational functions. Okay. Yeah, at least for the math, I have more control over how that goes. So the top function isn't factorable. How do we get an x-intercept if it's not factorable, though? No, that should be a y-intercept. No, wait. They should have a y-intercept. They shouldn't have an x-intercept, though, right? I am upset. I got killed by a hunter. I don't think that's ridiculous. To be fair, I did shoot at that one person who was also probably a hunter. But like, I don't know, man. I was being nice way more than I was being mean. Wait, so even here, this doesn't agree with. Actually, well, I guess it does. I know it's loud. It's just, I just think it's crappy. Like they haven't done anything wrong. It's just the same way as when like freshies try to punch me out and I get mad. Like it's allowed. They're not doing anything wrong. I don't see the point. Like they're just making other people's time worse. Which I realize I'm a huge hypocrite because I did fire a shot at that random person, but there are also a couple people that I could have tried to kill that I didn't. So I don't know. I can't be that mad, I guess. So what's even going on with this? Like, what's their question again? And this is only just posted. I want to sure no one beat me to it. I get the same line as the slant asymptote. X squared plus x minus 2. Oh, wait. Oh, wait, this is factorable. It's x plus 2 times x minus 1. Oops. I don't know how I didn't realize that. So yeah, there should be an x-intercept in that case. X squared plus x minus 2 to x plus 2 times x minus 1. So the x minus 1 factors cancel. A linear function. Hey, Drew. Let me just verify that because I don't trust my brain to do math right now. Yeah, 2 plus x. Okay. Very deeply confused. D and E in terms of A, B, and C only? Really? You know, beat me to it. Doesn't seem like it. Let's try this one, because this one might be achievable for me. May get a cop drop too. Proof yet? You haven't answered an idiot. Oh, okay. I assume then they're not countable. You don't have a proof yet? Or I guess it could be either. It's kind of a crappy rendition. Okay, so BC is A. AC is B. AB is C. AD is D. CD is E. They don't name BD, I guess? No. It can't be countable. Wait, how's it finite and not countable? BB is A minus E? Yeah, Jed, I guess you're right. It will be finite and uncountable? I thought that's like a contradiction. Oh, okay. It can be either, but okay, that makes sense. So if two, I was just thinking that this is like a Jed type of problem, so I'm glad that you're here. 3 ABC. So I don't know if we want BAC, ABC. I assume we want to get like maybe BAC is equal to 3 over 2 ABC, and maybe the substitution will come in handy at some point. DAC is twice DAB. Okay. What's a dab angle? Oh, we got angle dab. Hell yeah. So I haven't figured out the angles. I think this is a law of cosines problem, right? So I don't see how else we go from angles to side lengths. DAC is X? Yeah, I was wondering if it'd be helpful if we did X and 2X there. The entire thing is 3X. Wait, should it be the other way around? That should be 1/2 X, right? Because dab is smaller. Well, wait. Yeah. No? I'm confusing myself. If DAC, it seems to contradict, like... I think, yeah, that's probably a better call, Jen. And the entire thing is 3X. And we know that we'd have a 3 there too. I don't know if that's, you know, helpful or not, but that is ABC is equal to 3x. We can relate that to BAC. Oh, BAC, not ABC, yeah. Oh, I was wondering if we get an isosceles triangle out of this. That'd be nice, but no, I don't think we do. (180 minus 5x), yeah. So I still think we need law of cosines in here. We might have to apply it to each of the 3 triangles in here. So, I mean, what do we want? We want to eliminate D and E. So, I don't know what angle we should choose. Maybe we choose this as our like pivot for the law of cosines and see what happens. So if we look at the big triangle, a squared equals b squared plus c squared minus 2 bc cosine 3x. So that's already a, b, and c. Well, we have to, or we have to, we can't have an x in there. Wait, no, we want only D and E. Wait, no, we want D and E in terms of A, B, and C. Okay. So we can't have an X in our final answer, but hopefully we can figure out some way around that. The ratios of the angles here might imply like a 30, 60, 90 triangle or something like that. I don't know how we would work that out. If, well, not necessarily. This is too general so far. We apply it now to, I guess, ACD. Still with angle A. A squared equals b squared plus d squared minus 2 bd cosine 2x this time. And for triangle ABD, a squared is equal to b squared plus c squared. Wait, where's E? Oh yeah, E is up there. Why didn't I get E in? Oh shoot, I messed up. We don't have A for ACD, ironically, or ABD. Because A is that entire length there. I was getting my things mixed up. This for ACD should be E squared. So we need to get rid of that D. And then this down here is A minus E, because we don't have that defined. Squared. Still D squared plus C squared. 2CD cosine X. Okay. So we want, I guess, this top one we want to get rid of D, the bottom one we want to get rid of E, or the other way around maybe. The cosines are, they seem like the biggest problem though. How do we do this? I thought this would be more clear once we applied the law of cosines, but it's really not to me. if the ratios of the angles... Well, actually... Oh, it's not a right triangle, though. Can you make a statement about a triangle just based off the ratios of its angles, I wonder? You've redrawn the 3 triangles, you're not seeing any similarities? Yeah. Three, two, one. Is that a 30, 60, 90 triangle? I think it is. The posters are moved. Oh, wait, this got deleted? I still want to work on this problem anyway, but ABC is similar to ABC. They share a side. They do have a 2x angle. Aren't they different angles, though? I'm having a hard time visualizing the rotation, but... I don't think we know they're similar. ABC, ADC. Maybe I need to draw them separately. What is ADB? I think it's potentially anything. Like 180 minus 3x is the best that you can say. I don't think that's a particularly helpful fact, though.
You are technically correct. The best kind of correct.
And what is ADC? Well, ADC is 180 minus 5x. Oh, no. I'm sorry. Well, I mean, if these are supplementary angles, I guess. Dude, I'm already... ABC, ADC. I'm looking at the wrong thing. Okay, let me... Well, okay, here, let me look at what you're saying. ADB is 180 minus 3x. ADB is 180 minus 3x, yes. ADC is 180... Okay, yes. Okay. So yeah, this also has a 3x and a 2x. And a shared side that's adjacent. So that's side angle angle. And I think that is a similarity. Side angle or angle side. Draw triangle ABC, then mirror ADC. Okay. We got ABC, and then we want to draw ADC. Well, ABC, I still need to... Wait, why did I label it like that? That's not right. Yeah. C goes on top. Now that's right, right? Then we want ADC? A on the right, C on top, D on left. Okay. Let me... And then 8 in D. Then from D to C is short, and A to C is long. Okay, yeah, so that looks like a B. Okay. D is 3x. A is still 2x, or not still, but it is 2x here. And then A to C is B. C to D is E. And A to D is D. Okay. Thank you for telling me the rotation. So, we get some proportions out of this. B over A equals E over B, and do the B's cancel? No, they don't cancel, but it's still, it might be a helpful substitution though, or something to use. B over A equals A over B. Wait, how do we get two A's in there? Oh, E over B. Sorry. So that's what I wrote for the first part, equals D over C. Isn't it C over D? Or no? B over A. No. I'm confusing myself. That B over that A. That E over that B. That D over that C. You're right. I was thinking my A's and B's mixed up. Yeah, okay. Okay. So, an expression for E, wait, can we just directly get the answer from that relationship there? Because if we, from that first one, E is equal to B squared over A. That's a thing for E, only in terms of A, B, and C. And D is BC over A. Okay, that's not, so law of cosines doesn't actually come into play, it seems. Oh my god, that's a horrible B. It's more like a beta. It's not even a beta. BC over A. Okay, that's surprisingly simple. You'd have to work out some angles, but yeah, you don't have that much of another option, I guess. It's a neat little problem. If anyone else beat me to it. Oh yeah, it got removed. I mean, I can still see the thread. Should I still just post anyway? As soon as I look at it through this angle, I won't see it anymore. Okay, yeah, I don't see it on the page anymore, I don't think. I think it was below this SAT one. I mean, they didn't post their attempt. We're like, what would if I were to DM them or just post it here, like, I might just call it a math for fun. Like if they repost the question, then we'll get to them. But I'd like to see them repost it with their attempt, ideally. I don't really want to go out and wait to DM them. So that feels like encouraging people to not post their attempt or what they're not understanding. Make it work algebraically. No one answered this one? Did they double post it? Similar to some trig integrals? I don't think I've seen one that's like that, but maybe. No, they didn't double post it, doesn't seem. Like, there's a few ways that you could do this. My first thing is just raise everything to 2 to the power of everything here. There are some log identities that you could do instead, but I don't know, it's kind of all the same. Is that a 1 or that has to be a 1? They just didn't write the bottom part. That'd be weird if it was a 7, right? Oh shit, log base 2 of root 2? Can you just evaluate that directly? That's 1/2. So let's just quickly do the right-hand side. Log base 2 of root 2 is 1/2. 1/2 times 6 is 3. 1 minus 3 is -2. We may as well apply some identities to the left side too. We're gonna mess with the right side. So we can bring this to inside as an exponent. Like that. The same over here. And let's do... We can take it a step further and apply the subtraction identity to that. And so it's this divided by that. 3 over 2 minus 4 is negative... something. 2.5. 5 over 2. Is that right? Yeah. So that becomes 8 over 2. And then now we can write it in exponential form. 2 to the -2 is 1/4. And then raising each side to the power of -5 or -2 over 5 to undo that. Because when they multiply down, that'll become 1 there. So first the negative sign that flips up and becomes a 4. The square root makes it 2. 2 to the 5 is 32. So x equals 32, I think. I do want to plug this into Wolfram just to verify. Third, 4 log base 2 of it, or minus 4 log. With x, excuse me, 1 minus 6 log base 2 of root 2. Negative 2? No. 2 to the 3 over 5? Excuse me. That actually might make sense. What mistake did I make, though? Did I just give it the left-hand side? Did I do that part right? Minus 10 over 3? Oh, I flipped the fraction. I'll look at that in a second, Anders. That should be 2 over 3, not 3 over 2. So that becomes 12 over 3. So minus 10 over 3. Yeah, okay. Now you do this in exponential form. That's 1/4. Now you do each side to the power of negative 3 over 10. What a weird exponent, man. And so 10 is 5 times 2, so there's a hidden square root in that. So that becomes, well, first the 4 flips up because of the negative sign, and then we squared it to get 2. And then we're left with 2 to the 3 over 5. So that's how you get 2 to the 3 over 5. Okay. Let's see what this is, Anders. Really? Oh, will you iterate it? I don't think this is the same idea. Or to me, this feels different. I guess I do see what you mean with this last step where you end up with 2 times something. I don't know if this is the exact same, though. Yeah, I think for the reason that Drew has said. Like, it is that same idea at the end there with, like, the 2s and then dividing by it, but it's not exactly the same. Maybe same idea, but different context. Something like that. First, log base 2 of square root 2 is equal to 1/2. Square root of 2 is 2 to the 1/2. One minus 6 times 1/2 is equal to negative 2. so 2 log base 2 of x to the 1/3 go to log base 2 of x to the 2/3, and four log base 2 x is equal to log base 2 of x to the 4th. Base 2 x to the 2/3 minus log base 2 x to the 4 will be -2. Two remaining logs. Into log base 2 of, and I think at this point I'm just going to say the division, but not going to do the division for them or any further steps. In general, the steps will be to evaluate that, then write the equation in exponential form. Okay, I think I'm gonna post this. Hey, Shep. It could have gone a lot better. But it happens. Hey, Ritesh. Yeah, sure. Central's fault? Yeah. I like that explanation. So you actually come at a good time, Ritesh, because I'll shoot between questions anyway. So we have the equation xy equals root x squared plus y squared. And our goal is to find dy by dx. Yeah, the coffee was great. So, I mean, it's probably overkill to write out this thing, but dy by dx of xy equals root x squared plus y squared. And so the implicit derivative is always a little like tricky for me because you kind of treat both, like you have to derive both x and y, and you treat y just like it's x, except anytime you derive y, you have to put a dy by dx there. This isn't a very theoretically sound explanation that I'm saying, but this is just how I remember to do implicit differentiation, and I'll kind of explain more about what I mean as we encounter it. So let's focus on the left side here. We have x times y. We have to product rule this. So I'm going to derive the x first, which becomes 1, so we just get y. Then plus, then we derive the y, so we just get x. But we just derived a y, so we need to put a dy by dx here. And that's because of the chain rule, but you know, the most important thing to remember is that if you ever derive a y, just multiply a dy by dx for that term. This is what you get for the left-hand side. I hope that makes sense, applying the product rule. No shot. Please go back to bed. Feel better. And now looking at this is gonna be a little bit trickier because we have the square root on the outside. So I have a way that I think I want to do it. I'm trying to figure out how valid it is. I think if we just treat this as one unit, ignoring that there's an x and a y there, you would take that 1/2 as an exponent and do your normal power rule with it. So you multiply it by 1/2, and then you do 1/2 minus 1 is negative 1/2. So this flips down to the bottom, still with the square root. And now because of chain rule, you have to derive the inside. So x squared becomes 2x plus y squared becomes 2y, but now we just derived a y, so we multiply by the dy over dx. And I believe this is true. What I was debating in my head is if we can technically derive y here, but I don't think so. Drew, it's a question that Retaj put in chat. So from here, we would have to do some algebraic manipulations to isolate dy by dx. X minus xy squared over x squared minus y minus y. Well, let me bring mine home and see what I get. There should be a square root somewhere in your answer, I think. But let's multiply this term inside here and see how it shakes out. So I need to get this dy by dx kind of free so I can look what my dy by dx is. So this times the 2x term first, the 2's cancel, so we get x over root x squared plus y squared. Plus, and then multiplying by this term, the 2's cancel, so we get y over root x squared plus y squared. Dy dx. Now we want to, this has a dy by dx, so let's get to the other side, and this y is alone, so let's get to the other side. Oh, hard lock. I was wondering if I was actually doing something wrong. I think I'm okay though. X squared plus y squared dy by dx is equal to x over root x squared plus y squared minus y. Now from here we factor out the dy by dx. Back from working, welcome back. So let's factor the dy by dx from the left side. It's gonna be a mess after the next step. Minus y. Okay. Now we're going to divide each side by this to isolate the dy by dx. So this goes on top, and this is where the mess is really going to come in. Oops. Okay. So technically that's an answer. Hey, Zone Ranger. Is that valid? Like, we can just do root x squared plus y squared equals xy. That isn't circular, though? That feels weird. I guess you are right, it is the first line, but that makes me feel uncomfortable for some reason, I guess. I guess that would make it a lot easier. This problem feels familiar now that you say that, though. Maybe I have done this before and I just don't remember it. All right, let's try it. That when the original equation holds. All right. So let's do, basically what Zone Ranger is saying is that if we know root x squared plus y squared is equal to xy, then why not sub xy over here and here for the root x squared plus y squared, or even earlier down there in the equation at some point. But I'm going to do it here. You could have done it earlier. So this, we have x there, and then that becomes xy minus y. I might not be right either, but let me get to the end here and see if we get something, or if we got something that's equivalent. Okay, so that's after we do the sub. Now we get some cancellations. 1 over y minus y, x minus 1 over x. And, I mean, you could do more with that. I might call that the answer. You could multiply by x over x and y over y, I guess. Get rid of some of these like fractions inside of fractions. And you get x minus xy squared over x squared y minus y. Final answer. And so let's look at what you put and see how close we are. Oh, you know what? I think we got the same answer. Yes. Ritesh, we got the same thing. The only difference between our answers is doing that substitution. So if you were to do the same root x squared plus y squared equals xy sub, you get the same thing as I just put for my last line. Okay, awesome. Thanks for pointing that out, Zone Ranger. Glad to help. If you have more, feel free to let me know. In the meantime, I'll see if there's, we're probably out of questions for Reddit, but let's take another look. Oh wait, we do have a reply here. X equals 2 3 over 5, that was right, I think. Yep. How do I say it's the right answer in a non-condescending way? Let's say perfect. What's up, Drew? say something about the answer? To the derivative? To the exponent one? Or log one? Or Anders? Shoot. Okay, I asked you too many questions. I see you mean yes to the derivative one. Yeah, you're right, Chad. Derivative? Okay. So I'm gonna reply to this person then. Apparently it's possible there's a mistake here for the derivative, so let's y equals 0. Well, when we divide out that, we can't allow that expression equal 0. Oh, but then our final answer doesn't hold for y equals 0? In the initial equation, or it should hold? I think you manually define it, or something like... I mean... For the purposes of Red Hatch's calculus class, I doubt that's that important. Usually when they ask you to take the partial, that you don't worry about that much about it, I feel like. But Red Hatch, what Drew is saying is that with this final answer, you technically can't have y equals 0, but you should be allowed to have y equals 0, because for the rest of the work, you are allowed to have it. But I assume what Zone Ranger said holds, or... I don't know exactly, but I don't think you need to worry about that for the purpose of just normal calculus class. Yeah, Drew, I feel like in every calculus class that I've taken, they always gloss over that. But I think you're technically right. It's for pre-calc? You're doing that in pre-calc? Wow, that's not what my pre-calc class did. This is some hardcore like calculus stuff. Okay. I don't think you need to worry about it, but technically there is a little like issue there that I assume you just would manually define the function if it was that important for y equals 0. Oh, really? I guess you went to a stricter school. So let's look at your other question, Retash. I think we've taken that one to the bottom, to the top, whatever. Find equation for tangent line to y equals, I assume that's 1 plus sine is the entire numerator over cosine x like that? Or is the 1 separate from the fraction? Yes, like this? Okay. Okay, so for this, the equation of the tangent line, we already have a point that the line passes through. We're given that in the initial problem. We need to find the slope of that line. Oh, okay, so you put two answers there, but they're the same equation, right? Just rearranged. Hey, Wish, perfect timing? What's up? You had a midterm on Monday. How'd it go? Or you have a midterm. Calc 1. Look, let me know if you need anything. Slope is 1, I'm not sure if it's right. So let's find the slope for ourselves then. So let's find y prime, or dy by dx, same thing. And so I guess we need quotient rule. Technically, you could do it a different way, but I'm just going to do quotient rule. Made your proofs midterm last Monday. That went well. That's good to hear. And I need to Google it again, the quotient rule. I'm pretty sure you derive the numerator first. I just literally always forget it. Yeah, you derive the numerator first. Good. So for quotient rule, we'll derive the numerator first. 1 derives to 0, sine derives to positive cosine. Multiply by the denominator. Minus, then the numerator as it's presented. Times the derivative of the denominator, which is minus sine x, over the original denominator squared. Now let's get some simplifications in here. Cosine squared minus, let's multiply this minus sign in and multiply the minus sign in. Well, that might, minus sine x times 1 is minus sine x, times minus 1 is positive sine x. Minus sine x times positive sine x is minus sine squared x, times minus 1 is plus sine squared x over cosine squared x. Now cosine squared plus sine squared is equal to 1. That's a Pythagorean identity. Oh wait. Low d high times high d low. I think we agree with each other, because if the d goes with the high, or the... That's... I think that's basically what I did. But I was going up this site with f of x over g of x, and you do derive f of x first, then times g of x. Is there something wrong with this site? I look at it all the time. I don't know what the site is like even about. It's Indian? Oh, okay. Honestly, it just comes up all the time in Google, so I don't even know anything about it. But I think we did do the same thing. I mean, I arranged it differently, but I think the basically the way that thing is Redtash is g of x times d by dx f of x, and I just did it the way that the website says here. So I think we did the same thing, just arranged differently. So we're doing integration. Ooh, oh, that's fun. It can be, some problems get a little tedious, but integration is really fun. Okay, so I think we're okay with this so far. We do know that cosine squared plus sine squared is a Pythagorean identity. That's equal to 1. So we can say 1 plus sine x over cosine squared x. And I don't see anything further to do with this to simplify it. So we can plug in pi and see what we get out of this. Y prime of pi is 1 plus sine of pi is 0. Cosine of pi is -1. -1 squared is +1. So yeah, I get 1 for the slope as well. Is that the correct point? At the point pi comma 1? I think so. Look back at Retaj's initial question. Yeah, at pi comma 1. Pi -1? Did I gloss over the minus sign? No, it is equal to, the initial function is equal to +1 at x equals pi. What? That I just copy pasted what Red said. It was initially in that when you plug in pi into that initial y equation, you do get 1. You should. Sine of... Oh wait, shoot, I'm sorry, I'm misreading it. It is -1. Oh shoot, I was misreading the initial one. It's taking too long. Yeah, pi, it is -1. Because 1 plus 0 over -1 is -1. Or pi comma 1 just... That might be a typo. I'm more inclined to think that's a typo, Retash. And it's supposed to be pi comma -1. But yeah, technically, if you're assuming that the question is right, it wouldn't exist because there is no tangent line, or there's no point to make a tangent line with at pi comma 1 for this function. So we can still follow the math. If we take it as pi comma -1, we can still follow this math through. But if the original question was pi comma 1, then I guess it wouldn't exist. And so if we set up, it's not much more math anyway, so I'll just show it. If we set up y equals mx plus b, m is +1 plus b, and we need to figure out what b is, so let's plug in our x and y. -1 equals pi plus b. Solving that for b, you get minus pi minus 1. So your final answer should be for the tangent line is y equals x minus pi minus 1. That is weird about the point. I think if you didn't notice that about the point being wrong, your math is right though. But the question isn't well made. So yeah, I'm sorry, I'm not sure what else to tell you, Retaj, but I hope that makes sense for... It's kind of... Yes, that's also valid. So it's just rearranging the final answer. But yeah, I hope that's okay with you besides that one like weird part.